the application of the chain rule. So this is going to be practice. Okay, it's going to be practice quiz number 2. So the concept or the topics that's going to be covered on this quiz are going to be, that's it, the chain rule. It's going to be chain rule for the ordinary function and the chain rule for the trigonometric function. Okay, then implicit differentiation. So that would be implicit differentiation. Okay, we give you 2 questions on this. So chain rule, implicit differentiation. Then we put both of them together and we are going to have new tangent line problems. Okay, tangent lines problem. Or tangent line problem. It's going to be 2 types, the functions that you have to use the chain rule in order to get the derivative to make it the slope. And the second part is going to be an equation would be given to you, which is defined implicitly. Then you have to use implicit differentiation to get the slope of a tangent line. Okay, so that's going to be the chain rule, implicit differentiation, tangent line problems, and of course, a related rate. Related rates. So 6 questions, among these topics for your quiz. Okay, so we're going to practice the number 1 on your list. It's going to be finding derivative of the function using chain rule. That's a type 1 that you are going to use only the power rule formula. Okay, so that's question number 1. Find the derivative. Find the derivative of each function. Derivative of each function. For this group, the only formula that you need is this one. If u is a function of x, derivative of u to the n, okay, action of differentiation, remember, we bring the power down, it's going to be n, u to the n minus 1, but you have to multiply by u prime. It's a composition of 2 functions. One of the function is a power function to the n, the other function is the u function. Okay, there are 4 possibilities, but when you think about it, put it together, it's only 2 possibilities, and that's it. The first one, or type 1. The type 1 is this one, f of x equal to, okay, f of x equal to the x cubed minus 3 cosine of x, everything to the 6. That's it. That's the type 1. As you can see, if you think about the inside to be equal to the u, then you realize that you are doing u to the 6. It's just for your information on the quiz. You don't have to write it down, but you remind yourself, you see the solution. You remind yourself that the formula that you have to use is u to the 6. Okay, and just copy the formula. You bring the power down, 6 u to the 1 down, 5 times u prime. Now you simply copy that formula. So that's it. F prime of x equal to, bring the power down, 6 x cubed minus 3 cosine of x, 1 down, 5 times u prime. U prime derivative of the inside. Derivative of the inside, 3x squared. That's minus 3 times cosine. It's going to be minus 3 times derivative of a cosine. But derivative of a cosine is a negative sign. So that makes this one into the positive, and that gives you 3 sine of x. And that's it, you're done. The simplification, we talk about it if there is going to be any monomials here. Any monomial, a single term, you just multiply by the 6 and you put it up in front. Otherwise, no more action is needed, and then we are done. That is type 1. Any question? Straightforward type. So what's going to be type 2? Type 2 is going to be kind of a radical function. It's the same thing, but you may have to do it. So on the quiz, it's in the part D, but I want to have all of them in order that we have to study. So the function is k of x. So k of x is equal to, it's a fifth root, okay? It's a fifth root of x squared minus 2 10x. Okay, that's going to be, you get a single radical or a radical expression. And now we know that we don't like radical in calculus. So the first thing to do, you have to rewrite it. Okay, so the solution is going to be, rewrite it first. So it's going to be k of x equal to x squared minus 2 10x, everything to a fifth. You see, so that take you back to the same the previous method. So again, you think about it. You think about the fact that you may call this one u. So you realize that you do have u to a fifth. So if you want to differentiate u to the fifth, you bring the power down. You see, copy the formula in this case. So that gives you a fifth. Okay, u to the a fifth minus 1, 1/5 minus 1. 1 minus 5 would be -4. We get -4/5 times it by u prime. Okay, so we just copy this formula here. There you are. So the k prime of x is going to be equal to power down, that gives a fifth. Okay, x squared minus 2 10x to the -4/5, 1 minus 5. So -4/5 times it by u prime. U prime derivative of the inside, derivative of x squared, 2x. It's a 2x minus 2 times tan is going to be minus 2 times derivative of the tan. Derivative of the tan is secant squared. Secant squared of x, and then you're done. Again, no simplification is possible because this is not a monomial. So that would be the end of the problem. Any question? So it's the same type, we call it. Okay, so instead of this one, you may be given a radical expression. But in calculus, we don't like radicals. So we switch it first, and then we get to the u function again. Okay, any question? So this is a possibility for the type 1, if you like, because you are going to have two questions, two parts on this one. And this is going to be the first part. Now, the next one is a little bit more challenging. So that's going to be the next one here is part B. This is going to be a combination of the chain rule. Okay, a combination and the chain rule and the product rule. So that would be the case that we are going to have. Okay, so there you are. So what's the problem? The problem is function is g of x. Okay, g of x equal to the x squared. Okay, the fifth root, x squared, the fifth root of 4x to the fifth plus x squared. This is the function. Now you know that the first thing to do, you have to rewrite it because of this radical. So we rewrite it first. So this is it, the solution. If we rewrite it, we arrive at the g of x equal to x squared times it by 4x to the fifth plus x squared, everything to a fifth. Now the difference between this problem and the other one that we did is the fact that it's a product of two functions. You see, the first function is x squared. So that would be the first function. And the second function is going to be a kind of U type. So you realize that you have to apply the product rule. So remind yourself that I have to use the product rule. So the product rule would be derivative of the first, okay, times it by the second one, plus derivative of the second one, times it by the first one. So that's the difference between this one and the other one. You have to apply the product rule as well. Now, to take the product rule, the derivative of the first one is easy. The derivative of x squared is 2x times it by the second one. But the second times first is u to the fifth. So you have to apply the chain rule for the second one. Okay, so that's a characteristic of the type 2 that we call it. So the derivative of the first times second, second first, is always the case that for the second, or one of them, you have to apply the chain rule here. Okay, so there you are. G prime of x is equal to derivative of the first one, derivative of x squared, 2x, times the second, 4x to the fifth, plus x squared to a fifth. This is going to be untouched, derivative of the first times second. Now second first. Second is u to the fifth. You see, you bring a fifth down. So this is going to be plus 1/5. Okay, everything else will stay the same. 4x to the fifth plus x squared to the negative 4/5. Negative 4/5, but remember times the u prime. U prime derivative of the inside. That's a 4x to the fifth, so 5 times 4, 20. 20x to the fourth plus 2x. So that will be the derivative of the second one. So for the second one, you have to apply you have to apply the chain rule. Now that's the derivative of the second one, times it by the first one. The first one is x squared. Some people, they miss this one, but this is the product rule. So you have to times it by x squared. Okay, that's done, but usually like to bring this monomial up in front in case it can be simplified. This cannot be simplified. So even if you write it down, it will be fine, but get used to it. So I'm going to rewrite it as g prime of x equal to, it's a 2x times 4x to the fifth plus x squared, everything to a fifth. Now I have plus 1/5 of x squared. Okay, times it by 4x to the fifth plus x squared to the negative 4/5 times it by 20x to the fourth plus 2x, and then you done. Okay, that's customary to write it down in this format. In case if it was something like 2x squared, 3x squared, then you multiply the numbers, the coefficients. Otherwise, this would be the final answer. Any question? So be careful. Just recognize it first that it is a product rule, a product of two functions. So apply your product rule formula, but be aware that the second part, of course, is the u type. So it's like u to a fifth. So it's going to be 1/5 u to the negative 4/5 times u prime. You have to have a second times first and take care of the monomials. Any question? So that's the type 2 with the product. Now, we have one more type. That's when you have a quotient, and then you have the option of changing it or just staying with it, okay? So I'm going to go to the next one. So it's we give you one question, it's going to be 2 parts, and we combine these 4 cases into 2 cases, and we give you the one on your next quiz, next test, and on the final. From this quiz, something like, kind of 2 questions from this quiz would be repeated on the final. And this is the only thing that we carry from the first part of the course. Okay, so what's going to be the other case that we have? Case C. We want to do the same thing for this one. So that would be h of x. H of x is equal to the 3x squared plus 7 secant of x. That's on the top. Down the bottom, it's 8x plus 1 to the 4. You say it's a quotient function. It's a rational function. So you have 2 options. The first one, of course, is a quotient rule, derivative of the top times bottom, bottom top. But as I talked about it before, in calculus, you see the only time that we use, you better use quotient rule is when there is no power here. Because when you use the quotient rule, then you simplify it. So that would be easy, the only one. But any time else, okay, any other time, you move it up. When you move it up, it would be product. And you already talk about the product, you see. You don't have to do it twice. But that's a suggestion. If you don't like it and you want to use the quotient, it's up to you. But this method is going to be used later on. Okay, this habit, if you like. So that's we prepare you for the future when we get to the integrations. But again, it's optional. Okay, so I usually move it up. So move it up, h of x is equal to, so the top one stay the same, 3x squared, 7 secant x. Now you move up this one, 8x plus 1 to a negative 4. You see, it's a product. It's a product of two functions, so that take you back to the, okay, to the previous case, the product case. So remind yourself that it's a product of two functions. So this is going to be your first function, okay? And this is going to be your second function. So remind yourself that you are going to apply the product rule. That's the derivative of the first times second and the second first, as we did it for the other one. Of the first one is ordinary differentiation, but the second times first is u to the negative 4. U to the negative 4, okay? So you may remind yourself that if I want to find derivative of u to the negative 4, then you have to use the chain rule, bring the power down, negative 4, u to the 1 down, negative 4 minus 1, negative 5, times that by u prime. Not bad to make a note for yourself of what you are going to do or what you expected. Okay, are you ready? Differentiate h prime. It's going to be derivative of the first one. We need a parenthesis. 2 times 3 is 6, so it's a 6x plus 7 times secant is going to be 7 times derivative of a secant, which is secant tan. So secant x, tangent x. Okay, so that would be derivative of the first one. Times it by the second one. So it's going to be 8x plus 1 to the negative 4. That's the derivative of the first times second. Okay, now second first plus second first, but the second one is u to the negative 4. Power down, negative 4, 8x plus 1, 1 down, negative 4 minus 1, negative 5. Negative 5 times u prime. U prime derivative of the inside, derivative of 8x plus 1 is simply 8. Any question? So that's the derivative of the second one, but you have to times it by the first one. So it's going to be times 3x squared plus 7 secant of x. Okay, so that would be the derivative of the second times first. But you have monomials here, you see. You have the 8 and the 4. Have to multiply them together and we put it up in front as a coefficient. So it's going to be h prime of x equal to, you get a 6x plus 7 secant of x, tangent of x. Okay, repeat this one, 8x plus 1 to the negative 4. Now 4 times 8 would be 32. So minus 32 times 8x plus 1 to the negative 5 times 3x squared plus 7 secant of x, the final answer. You see? That would be easier. That would be easier to handle. In future, if you want to do anything else, then we change these negative powers into the positive. But otherwise, this is it. This is going to be the derivative of the function and the last case. Any question? So just focus on two types really. That the u type that we have, okay, just power of the u function, power function, power of a function. and then the product. If you have a quotient, you change it to the product, unless you don't like it. I've seen some people, they like a quotient rule. Yes, you can use the quotient rule. Lift of the top times bottom minus the lift of the bottom times top. Okay, divide by the bottom square. I can do it, but I prefer this one. Okay, but I've seen people, they like quotient rule method. Okay, that is going to be the second method. Okay, second method, if you like. If you want to do the second method, this is going to be, so that's going to be your option. You don't have to do it. Okay, option 2, if you like. Option 2, quotient rule. Okay, quotient rule, but I prefer this one for future. But if you want to do the quotient rule, there you are. H prime of x equal to, okay, H prime of x is equal to derivative of the top times bottom. You see the quotient rule? Top, bottom is going to be derivative of the top, t prime, times bottom, minus derivative of the bottom, b prime, times top, divided by the bottom square. So you have to apply this formula. Let's see what would happen to it. And this is it. Now derivative of the top is going to be 6x plus 7 secant tan. Secant tangent. You see, that's derivative of the top. Now times it by the bottom. Times it by the bottom. It's going to be 8x plus 1 to the 4th. That's derivative of the top times bottom. Now minus derivative of the bottom times top. Derivative of the bottom would be chain rule. So it's going to be minus, you bring the power down, 8x plus 1 to the 3rd power, times u prime, which is 8, as we did it here. So that's the derivative of the bottom one. Then you have to multiply by top. Okay, sorry, I don't have, just write down here. The top is going to be 3x squared plus 7 secant of x. That's going to be the top. Divided by the bottom square. You see, it's going to be 8x plus 1. You already got the 4, then you square it. You make it into the 8. Then you have to simplify this one for us. You see, when you do it, they don't accept it. And the simplification is going to be, you see this one, when we get old power and the new power, you multiply them together. So that gives you 8x plus 1 to the 8. Okay, that's going to be the 1. But to simplify it, you see we get 8x plus 1 cube, 8x plus 1 to the 4th. Then you have to factor out the 8x plus 1 to the 3rd. You see this is the simplification. It takes time because you have to do the simplification. That's not bad. So if you want to simplify it, you have to pull out the 8x plus 1 to the 3rd, then get the leftover. So the leftover would be 6x plus 7 secant x tangent x. Okay, this one times it by 8x plus 1. Okay, so this is what we got from the first. From the second, this 8x plus 1 cube would be done. 4 times 8, 32. So that gives you minus 32 times 3x squared plus 7 secant of x. And on the bottom, you have 8x plus 1 to the 8. Then you simplify these two. So 3 out of 8, that left, you leave you with 5. So the final answer, h prime of x is going to be equal to, you see, look at this, 6x plus 7 secant x tangent x, okay, times it by 8x plus 1, and that would be minus 32 times 3x squared plus 7 secant x divided by 8x plus 1 to the 5th. Okay, that gives you the 1. Then you have to go on because you get these, you just FOIL it, simplify it, And at the end, you get, you get a very fair description. So I'm going to do it so that you can see it. Avoid it, just do the other method on the test. But if you see it in your book, or sometimes when you check the solution, you see this type, don't be surprised. Okay, so you have to FOIL this one, 8x, so that give you, okay, so we get a 48, I just FOIL it, multiply this one, x squared, then that give me, okay, that give me 56x. It's a very, long procedure in our algebra. Then you multiply the one, which is going to be 6x plus 7 secant of x, tangent of x. Okay, so this is the first one. You have to do the same thing to the other one. So that give you 96 x squared, and that would be minus 7 times 2, 14. Okay, 21, 22, and that give you secant of x. See, it's all algebra. Because in calculus, the only thing that we do to the derivative, we want to find the rate of change. So a number would be given to you, you want to check that number, so we check it here, rather than doing this type of operation. But anyway, let's finish it. So this is it. You combine the like terms on the top. What you have is this one. You have the 48 and you have a 96. You subtract it. That give you again a negative 48x squared. Okay, so these two would be out. Then you have secant tan here. You can simplify it. So it's just 56 x secant x tangent x. You have to repeat everything, you cannot simplify anything else. That is going to be 6x 7 secant tangent, and eventually minus 2 to 4 secant x over 8x plus 1 to the fifth. Okay, so that's why I prefer to avoid it. Okay, it's no option. It's not a good option, but nice option is change it to the product. Change it to the product and just apply the derivative of the first time. Second, you don't have to simplify this, you see. If you want to do in future anything else, you maybe have to find h prime of 1, h prime of 2. So we substitute, then we simplify. Okay, I just did it so that you know that it takes time to do it. But we do this only if we have no power here, you see, the quotient rule. If this power is missing, you better do the quotient rule and simplify it, because that's easy. Anything else, avoid it. Move it up all the time. Okay, any question? So that will cover our first question on that quiz. Okay, so the first question, one question, a couple of these cases that you see. It's two cases for us, as far as we are concerned. One is a parenthesis ratio something, the other one is either a product or a quotient. If it's a quotient, we change it to the product. So only product all the time. Okay, question? That is your first question on chain rule. The second question on the chain rule, of course, the second question basically is going to be derivative of the trigonometric function. Remember, we have two types of problems, ordinary one, and this is the one that you may have to use the product rule or the quotient rule, no chain rule. But the other one is that you have to use the chain rule. Okay, so again, it's going to be two parts. One part with the ordinary function, and the other part with a application of the chain rule. Okay, so let's see what we have over here. Again, keep these solutions for your next test. So question number 2. This is going to be trigonometric function, derivative of trigonometric function. We want to find the derivative. Okay, find the derivative of each function. And they are going to be trigonometric function. Okay, of each function. It's a kind of 2 groups or 3 groups of problems. So the first group is just we're checking derivative of the ordinary trigonometric function. No change rule is needed. You may need the product rule or you may need the quotient, okay? So that would cover problem number part 1 and the part 2. Okay, so that's going to be part 1. Part 1 is the famous quotient. So it's going to be sine x divided 1 minus cosine x. So it's a quotient of trigonometric function. That would be our case 1. Again, you see there is no parentheses here. We talk about it. If there is no parentheses, no power, apply quotient rule only. Okay, this is the case that we don't move it up. Okay, already solution, we go on. Apply the quotient rule. Derivative of the top times bottom. Remember, you have to start with the top. Some people, they do the other way around. Derivative of the top times bottom. That's it. Derivative of the top, derivative of sine, cosine. Cosine x, put it inside parentheses, times derivative of the bottom. The bottom, derivative of 1 is 0. Minus, derivative of the cosine. Derivative of a cosine is a negative sign. So it's going to be negative, positive sign. Oh, I'm sorry. I made a mistake. Derivative of the top times bottom, okay? Sorry. So I already got the top, so there's going to be 1 minus cosine x. That's the first part. Okay, derivative of the top times bottom. Now minus, parentheses, derivative of the bottom. Derivative of the bottom, derivative of 1 is 0. Minus, derivative of the cosine. Derivative of cosine is a negative sign. So make this one into a positive sign. Positive sign. Times the top, sine x. Okay, so derivative of the top, cosine times bottom, minus derivative of the bottom, derivative of 1, 0. If of a cosine is a negative sign, there is a negative also here, but put it inside the parentheses, times top divided by the bottom squared, 1 minus cosine x all squared. You have to simplify it because you use the quotient, and this is y prime. Okay, you have to simplify, so continue on the top. Do the multiplication first, cosine inside, that give you cosine x. And cosine, so they go minus cosine squared. We continue here, it's going to be minus. And that's going to be sine times sine, which is sine squared. 1 minus cosine x all squared. Okay, then check to see if we can simplify it. Any suggestion? Can you simplify it? You see any familiar trigonometric identity on the top that enable you to simplify this one? On the top. You see, this is a negative cosine squared, negative sine squared. If you pull out the negative sign, you see, this identity is very popular. It's come in various places. So it's going to be cosine x. If you factor out the negative sign, so that give you cosine square of x plus a sine square of x. And this is 1 minus cosine x all squared. You know the Pythagorean identity for the trigonometric function. Cosine squared plus sine squared is equal to 1. So that would be 1. They arrange it so that you use this idea. Okay, so that's it. Y prime would be cosine x minus 1 divided by 1 minus cosine x all squared. You see that's 1. But you can simplify it further. You see this is 1 minus cosine, this is cosine minus 1. They are opposite of each other. You can pull out the negative sign on the top. Make this a negative 1 into the positive, and that would be negative cosine. And now you have 1 minus cosine x all squared. Now these two would cancel out. So the final answer would be y prime equal to -1 on the top and 1 minus cosine x on the bottom. That would be the final answer. Some people, they don't like this negative, so they bring it down, multiply by the bottom. If you want, this is going to be 1 on the top. You make this one into positive, so that give you cosine x minus 1. So that give you the final answer. It's a very popular problem, but remember during the lecture, I changed this one into 2 that make it more interesting, 2 minus cosine, and I gave you this one as 2 different functions, so check that. So sine over 2 minus cosine, sine over 2 plus cosine is the function. They are going to be the function that you have to remember it for future. Okay, so this is where we use the quotient rule, not for the other one that I did. We use the quotient rule because down the denominator, there is no power function, anything. Okay, this is the case for the quotient, just to remind you that you may have to use the quotient rule for the trigonometric function. That's the case 1 of the differentiate the function question. Case 2 for the product. So again, this type of function is going to be popular. So for the product, it's going to be just a power of x. In this case, it's x squared. Okay, times the secant x. You did have this on your quiz, on your test. This type of problem. You just repeat it because you may have to use it for the chain rule. Okay, so it's a product of 2 functions. So that's going to be the first, and that's going to be the second. So we apply the product rule, y prime. Derivative of the first 2x times the second 1 secant plus derivative of a second times first. Derivative of a secant is secant 10 times first. We put the monomial up in front. It's going to be x squared secant x tangent x. Okay, I think you did have this one on your previous test. And no simplification is possible. So this is the end of the problem. Okay, derivative of the first 2x times the second function. Second first, the derivative of the secant 10, we put the monomial up in front. Otherwise, you have to apply a parenthesis here and then multiply by x squared, as we talked about it before. Okay, so that's a product rule. Since you get it on the test, probably you are not going to get it again on the, okay, on this quiz, but it's good to know. Okay, so we gave you both of them before. So that is the case 1, but the case that we are going to be interested in the case with the chain rule. So there are 2 possibilities. So expect the following for the quiz. So what's going to be the other case? The chain rule, the type 1, is going to be, you see this is going to be the chain rule and the trigonometric function type 1 chain rule. So in this case, you are going to have a derivative of composition of 2 functions. Remember the formula that we use was this one, derivative of g of u is g prime of u times u prime. It's composition of 2 functions, but this last part over here, it can be sine, cosine, tangent, secant. So if it is going to be sine of u, not x, it's going to be derivative of the outside. Derivative of a sine is cosine of u, but you have to pay for it, u prime. See, that's a cosine. Case with the cosine. So you may be given cosine of u. Derivative of the outside, derivative of cosine is a negative sine of u times u prime. And you may be given tangent of u. Derivative of outside, derivative of a tangent secant square of u times u prime. Or you may be given secant. That's a number 4. you may be given secant of u. So derivative of the outside derivative of a secant is secant tan, secant of u, tangent of u, then times it by u prime. That's a case one, or the chain rule of the trigonometric function. Okay, you have four possibilities. You will see one of them. Okay, and these are going to be the one that we have. Any question? So I just listed the formula that you need. So now you know what you expect. So what is going to be the cases in this practice one? So the case that you're going to have, the first one is part, you have only one, part E. They give you the case with the tangent, okay? So it's going to be part E. They ask for the derivative of this function, y equal to tangent of radical x. You see, it's not tangent of x, it's tangent of radical x. So it's like tangent of u. Okay, so it's like a tangent of u. Just remind yourself, if it's going to be tangent of u, if of the outside tangent secant squared of u, but you have to multiply by u prime. So y prime equal to, if of a tangent secant squared of what? Radical x. You have to pay for it. Pay for it means derivative of a u, derivative of radical x. Remember, we talk about it. Just memorize it, is 1 over 2 radical x. Of course, you can write x to the 1/2 of x to the negative 1/2, but when it's a trigonometric function, this is the way we're going to write it down. And you have to put the monomial f in front. So it's going to be 1 over 2 radical x. Okay, 1 over 2 radical x secant squared of the radical x. So that would be the final answer. Okay, any question? So that would be case one of this group. Of this case one, part F is the same one. It's a product rule as well. So the function is y equal to x squared tan of 2x. It's a product of two functions. The first function is x squared, the other one tangent, so we have to apply the product rule. You see, this is going to be the first function. And this is going to be your second function. Carefully apply the product rule, y prime. If of the first 2x times the second one, tangent of 2x, plus second first. You see, the second one is of this group again. Tangent of 2x. Now, derivative outside, derivative of a tangent is secant squared. So it's going to be secant squared of what? 2x. But you have to pay for it, u prime. If of a 2x is 2. That's the derivative of a second one. Times it by the first one, x squared. But remember, monomials up in front. So the final answer, y prime equal to y prime equal to the 2x, tangent of 2x. And over here, the plus 2x squared. 2x squared, secant squared of the 2x. So that would be the final answer and the way you are going to do it. Any question? So that's the first group for the chain rule and trigonometric function. The second group, the power function, the power of this trigonometric one. We give it the formula, just remind you one of them. So for the next group, that is the chain rule formula. You see, we are going to have a power of the, for example, power of a sine to the n of the u prime. Remember, it's a 3 function. Power function to the n trig function, sine, u function. So the derivative is going to be, as we did it before, you do the derivative of the power function first. You see power function. Then you multiply derivative of the trig functions. Trigonometric function. Prime times u prime. This is the way you do the power of the trigonometric function. So for this problem, derivative of the sine to the n of the u would be, for example, power, you bring the power down, n sine to the n minus 1 times u. That's the power. Derivative of the trig function. The trig function is sine. Derivative of the sine, cosine. Cosine of u, then u prime. And you can do the same thing for the, for the tangent and the secant and the cosine. Okay, so this is you keep in mind how we're going to differentiate these powers of the trigonometric function. Again, they give you 1, and we have kind of 3 over here. Any question? This is the way you organize your study guide, if you like. Cases that we have here. You want to find derivative. This is the part C. A derivative of this function, y equal to the 4. Okay, 4 sine to the 5th of the 2x. You see exactly the same case that we need. This 4 is a number, it's coefficient, so we keep it. Power function. Power is 5, bring it down. 5 sine to the 4th of the 2x. That's a power function. Trig function. It's a sine, change it to the cosine of the 2x. Trig function. Times u prime, derivative of the inside, derivative of a 2x, 2. You see, that's it. The product of these three functions. So y prime, 4 is a number. Put it inside parentheses so you know what's going on. The first one, power. You just bring the power down, that's it. 5 sine to the 4th of the 2x. You are not going to take any other action. That's power. Derivative of the trig function is sine, cosine. But remember, cosine of the 2x. That's it. U prime. U is 2x, so u prime would be 2. That's it. Path monomials. We have 2, and we have 5, and we have 4. So multiply this together. 2 times 5, 10. 10 times 4, 40. So y prime is 40, okay, 40 sine to the 4th of the 2x times it by cosine of the 2x. That give you the final answer. Okay, so keep it in order. It would be a nice problem. That's one case that we have. Any question? So you can have it with the tangent and the secant. The case with the secant is very popular. Okay, so that's a part C. And the other one that you have is part D. So let's see if we can put the D here as well. Part D of this category, the function is a power function of a cosine. Y equal to the cosine to the 4th. Okay, of x cubed. Again, your power function, the power is the 4th. Your trig function is cosine. And the inside function is x cubed. See, 1, 2, 3, there's no coefficients. So solution, y prime. Power first, 4 down. 4 cosine cube of x cubed. That's a power function. Times it by the trig function, derivative of a trig, derivative of a cosine, negative sign. But remember, the angles are the same. Times derivative of the inside function, derivative of x cubed, which is a 3x squared. See, 1, 2, 3. Power for 3. Power for 3. Cosine, negative sign. X cubed, 3x squared. But monomials, coefficients 3, you have a -1 here, and the 4. So y prime is equal to -3 times 4, -12, -12x, -12x squared. Cosine cubed of the x cubed, sine of the x cubed. So that gives you the final answer. Okay, nicely keep it in order. That would be a nice problem. Okay, so this another powers. We give you more powers because this is more popular. And you get one of them on that quiz and one next test and the final. Okay, we have one more. Any question? So keep in mind, this is your formula for this group. We have one nice one with the secant and very popular. So let's do this one to finish this trigonometric function and the chain rule. So that would be part G. Okay. Part G, the function to differentiate is y equal to, we're going to y equal to the 2 secant to the 5th. Okay, secant to the 5th of the x squared. That's it. Again, 2 is a number, is a coefficient. 5 is the power. Trig function is a secant, and u function is x squared. So we go for it. Y prime equal to 2 is a number. First parenthesis for the power, 5, 4. 5 secant to the 4th of the x squared. Derivative of a trig function secant, derivative of secant 10. So that gives you secant of x squared, tangent of x squared. Remember to keep these angles the same. Times the derivative of the inside function. The inside function is x squared, and the derivative of x squared would be 2x. 2x. That's it. So monomials, the 1, 1, 2, and 3. So the coefficient 2 times 5, 10, 10 times 2, 20. So y prime is equal to the 20, okay, 20x. That would be 20x. And now the tricky one, the secant is, you see you have secant to the 4th here, and you have secant to the first power here. It's always the case. So you have to simplify this one too. So the power 4 and 1, you add them together, that gives you secant 5th. So make sure you simplify the secant as well. Okay, so, and then of course tangent squared. Tangent squared. So that gives you the final answer. So in the case of the secant, you have 2 simplification to do if you like. One of those are going to be the monomials that, we put them together. And the other one is because you get the extra secant, because the derivative of a secant is always equal to the secant tan. Okay, so there you are. We are done with all sorts of chain rule that you are going to be, the possibility that you can have. So 2 questions on the test, on the quiz, and the next test. So the question number 1 was ordinary chain rule. Those 4 cases, we break it into 2 cases. A trigonometric function, we are going to be interested in the chain rule type only. The chain rule type is you may combine the sine or the trigonometric function with another function. So it's a composition of 2 functions. You differentiate trigonometric function times du prime inside function. But if you have a power function, you have to take care of the derivative of the power. You bring the power down. You get the derivative of the trig function and the u prime, and that gives you the final answer. Okay, so the next problem is going to be tangent line. I give you a break now. So we come back, we do our 3rd problem for the quiz that we need. And that would be the tangent line problem. And that would be 2 parts. The first part, because the question is going to be the slope. So the first part, the function is explicitly given, is f of x equal to, okay, so there is no combination of x and y. And the second part is going to be the graph would be given to as a implicit equation, implicit define or implicit differentiation that you have to use. Okay, so the 902, so just have a break for 10, 12 minutes. We come back, we do that one, and then we go to the what is this related rates problem. So you already done only 2 problems for the quiz. We need 4 more. Okay, see you then. Okay, so we are going to continue before getting to the tangent line problem, because we are going to do the implicit differentiation and the ordinary one together. So let's do the implicit differentiation first, problem first. This is a number 7, so that will be our third topics. Okay, remember we did have 2 different types of differentiation. So this would be question number 7. We do this one first in this order. And this is what is implicit differentiation. Okay, implicit differentiation. Now, when we are going to use implicit differentiation, remember this is going to be the type that usually the function is given to you directly, explicitly, y equal to the f of x, so the derivative was f prime. But in this case, the function would be given as an equation mixed with the x and the y together. Okay, if this is going to be the case, and then you're going to be interested in finding y prime, or as is in your book, dy dx. So the way we do it, we differentiate this equation using a power rule formula. But when we get to the power of the x, derivative of x to the n, as usual, is going to be nx to the n minus 1. But when we get to the power of the y, so y to the n, you see y is a function. So we have to apply the chain rule, which is going to be n y to the n minus 1 times the y prime. Okay, because inside of x is nothing, but inside of y is a function of x. Okay, so when this is given to you, you use these 2 formula to differentiate it, and do you solve for y prime. Okay, so that's the instruction for the implicit differentiation. So any other previous formula like the quotient rule, product rule, everything are going to be used the same thing. Okay, so this is going to be number 7. We want to differentiate. So we would like to find the y prime in each of the following. Okay, the first example is, this is part 1. This is 7a, if you like. This is 7a. Find the derivative of this function. The function is going to be x cubed. That's a tricky one, in fact. Sine of y, okay, plus y cubed. And this is going to be equal to the 8x squared plus x. That's a tricky one that we talk about. It's here. Okay, you differentiate when we get to the x, use the power rule for the x and any other formulas. When we get to the y, remember y is a function of x. You have to use the chain rule. So the solution for this one is going to be, we have to use the product rule, because this is going to be derivative, this is going to be the first function, and this is going to be the second function. So derivative of the first times second plus the second first. If of the first one is easy, it's going to be 3x squared, okay, times the second function sine y. Now plus, if of the second times first, sine y, you have to use composition function chain rule, because sine outside function is sine, inside function is y. It's like sine u. When it's going to be sine x, derivative is cosine x. But it's a sine y, so you differentiate as usual. Derivative of a sine y would be cosine y. You multiply by y prime. Y prime. Okay, make sure don't miss this. That's the derivative of the second one times the first one, x cubed. Okay. Any question? Plus derivative of the y cubed. Power rule would be 3y squared, but we have to multiply by y prime, or d by dx, whichever you feel comfortable, equal to derivative of 8x squared would be 16x, and derivative of x is 1. Remember, both sides of the equation. Now you have to solve for y prime. Solve for y prime. So we isolate the y prime on one side of the equation. So, I just put the monomial up in front for this one. So I make it to the x cubed y prime cosine of y. Then I have the 3y squared y prime. Anything else goes to the other side. we subtract. So that would be minus 3x squared sine y. Okay, we cannot combine this together. They are different. So you pull out the y prime as a factor because you need the coefficient of the y prime. So that gives you x cubed cosine of y plus 3y squared. And on the other side, we have a 16x plus 1 minus 3x squared sine y. Now we divide by the coefficient of the y prime. See, this is the coefficient of the y prime. So y prime is going to be equal to, on the other side, we get a 16x plus 1 minus 3x squared sine of y. And on the other side, this side, we get the x cubed cosine of y plus 3y squared. So that would be the final answer. Any question? So be careful about the sign. If it's going to be sine y, see the y is inside. Anytime you differentiate respect to the y, respect to the x, and there is a y, you have to end up with the y prime. You see that's a y prime. Okay, don't miss it. It's a chain rule, outside cosine, inside y prime. And the other part's going to be easy. So this is the way you're going to find it. We talk about it. There's a shortcut for this, but you can't do it in calculus 1, remember. And that's using the function of 2 variables from calculus 3. So that's type 1. Any question? We give it 2 of these. Okay, one of them would be like, this is sine y. They may give you sine y, cosine y, tangent y, secant y. They want to see if you are going to miss this y prime here. That's the idea, okay? And remember, this is the product of 2 functions. So you have to apply the product rule. That's case 1, 7a. There is one more, and then we're done. Okay, so easy question on this, usually for your this quiz and the next test. So that is 7, but it's a 7b. Again, you want to find the y prime, and your function is your implicit equation, in fact. You have the x cubed, okay, minus xy plus y to the 5th. And this is equal to the 4x minus 1. And again, you've been asked to find the y prime. Okay, then apply the product rule, apply the differentiation to both sides. And the first one, 3x squared right away. But this is the product of 2 functions. You have to apply the derivative of the first times second, second first. That's the point about this one. And the y to the 5th is easy. So that's the first, that is a second. Okay, so the answer is going to be 3x squared minus 1. You better open up the parentheses, apply the product rule first, and then apply this negative sign. The first function is x, the derivative of x is 1. I just write it down to see what's going on. So it's going to be 1 times y. Plus the derivative of a second times first. The second derivative of y prime, times the first one, xy. Okay, derivative of the, derivative of the second is y prime. Okay, derivative of the first times second, derivative of first 1 times y. Second one is y prime times the first one plus derivative of y to the 5th, 5y to the 4th, but y prime. And on the other side, the derivative of 4x is just 4. Any question? Apply this negative sign carefully. 3x squared minus y minus x y prime plus 5y to the 4th y prime equal to 4. Have to isolate the y primes. So we keep this one as is, negative x y prime plus 5y to the 4th y prime equal to, you got the 4 here, just subtract the other parts. So it's going to 4 minus 3x squared plus y. Again, you cannot combine them together. Pull out the y prime as a factor. So that gives a negative x plus 5y to the 4th. And this is going to be 4 minus 3x squared plus y. Divide by the coefficient of the y prime. So the y prime is going to be equal to 4 minus 3x squared plus y divided by a negative x plus 5y to the 4th, and then you're done. So that is implicit differentiation, and that question number 7. Okay, so expect one, 2 parts for your quiz. Any question? Now we are ready to take the problem of the tangent line. Okay, so the tangent line problem in this section, you know that we need the slope. A point would be given to you, have to find the slope. So we are going to give the example that you have to apply the chain rule and you have to apply the implicit differentiation. There's going to be 2 parts. It takes time a little bit because this problem would have 2 parts and you have to give us all the details. Okay, so this would be problem number 3, and we want to find the equation of the tangent line. Okay, so find the equation of the tangent line. Okay, this is question number 3. When you find the equation of the tangent line to the given graph, graphs at the given point. Okay, that's it. There are going to be 2 groups. The first one is going to be the chain rule, the chain rule type. So the part 1, the function is f of x. It's going to be a radical function. Okay, it's unavoidable. So it's a 3x squared minus 2. This is the function, and you want to do it at the point. Okay, at the point 3 and 5. So we want to find the equation of a tangent line to the graph of that's graphs. Okay, to the graph of these functions, but at the point 3 and 5. You know that you need a point. The point is already given to you. Okay, so we have a point. So we call it the point P, which is equal to the 3 and 5. You need this slope. This is calculus. The slope is derivative. The function is f, so you have to find the f prime, and then you have to find it at x equal to 3. So this is going to be your job. Okay, to find the derivative. To find the derivative of this function, you know that you have to rewrite it first. As soon as you write it, then you have to apply the chain. Okay, so there you are, f of x equal to rewrite 3x squared minus 2, everything to a half. That's your function. You want to differentiate it, just think about it. It's like u to a half. So you have to apply the chain rule. Chain rule, bring the power down, 1/2 u to the 1/2 minus 1, negative 1/2 times u prime. This is just to remind you the formula that you have to use. Okay, operate f prime equal to same thing, bring the 1/2 down, 1/2 3x squared minus 2 to the negative 1/2. But u prime, lift up the inside, lift up a 3x squared would be 6x. Okay, simplify monomial, and that's it, 6. So that gives you 3, put it up in front. So you end up with, what? 3x times 3x squared minus 2 to the negative half. This is going to be your f prime of x. Where do you want it? At 3. So substitute carefully. F prime of 3 equal to, it's a 3x, 3 times 3. Okay, times it by inside parentheses. 3x squared, 3 times 3 squared minus 2. Then everything to the negative half. Simplify. 3 times 3 outside would be 9. Inside the 3 squared, 927. 27 minus negative half. 27 minus 2 would be 25. Negative half is going to be 9 times. 25 to the 1/2 is radical 25, which is 5. But you have a negative power here, make it to the 1/5, a fifth. So the answer would be 9/5. Any question? So just double check, make sure you don't miss this last part. So it's 25 to the positive 1/2 is a radical 25, which is 5. But since the power is negative, it becomes 1/5. So that's it. The slope is going to be, the slope is 9/5. Okay, any question? So we got the point because it's given to us. We want to find this slope. The slope is derivative, so we have to differentiate it. We rewrite the function. We realize that this is this is a radical function related. So it's going to be u to the 1/2. We apply the chain rule. Now, formula. This is it. So the point P is 3 and 5. So the equation of a tangent line is going to be what? Y minus y1, y minus 5. It's going to be m 9/5 times x minus x1, x minus 3. Now distribute this one inside. So it's a 9/5 of x minus 3 times 9, 27/5. Move the 5 to the other side. So y equal to 9/5 of x minus 27/5 plus 5. So it's going to be 27 minus 25, negative 2/5. So it's going to be 9/5, okay? And this is going to be 9/5 x minus 2/5. 5 times 5 would be 25, positive 25, negative 27, 27, that give you negative 2. So this is it, the tangent line. It's going to be 9/5 x minus 2/5. This is going to be the equation of a tangent line to the given graph, and then we're done. Any question? So that would be part 1 of the actual problem that you're going to see, okay, the tangent line problem. We give one with the chain rule, one with the implicit differentiation. The chain rule one mostly this one. You have another one here, I check it for you, but just give you one of them. Any question? So the tangent line problem is always with us, okay? So we have one more of these. Let's check that one too. That would be easy, but they like it. The radical one, just they want to check your ability to differentiate those radical functions. But the second one is going to be 3b, if you like. Your function is, this is it. Your function is f of x equal to the 2x cubed plus 1 squared. And your point is at, the point is a negative 1 and 1. That's it. Sorry. So again, same thing, the point is already given. So we have the point. We have the point, which is a negative 1 and 1, no problem. We need the slope. Function is f, so f prime at negative 1. So this is what you have to find. So you have to find the derivative is like u squared. Some people, they square it first and then differentiate it. You can do it, but the chain rule is the one that we're going to use. Okay, so in order to find this one is going to be f prime. So u is squared. You bring the power down, 2x cubed plus 1. Power down, 2 minus 1 would be 1 times the u prime. U prime derivative of inside, which is a 6x squared. Okay, so I use this formula of derivative of u squared, which is going to be 2u prime. This is the value used. Any question? Simplify, then substitute. You have a monomial to take care of. 6 times 2, 12. So we get f prime of x equal to the 12 x squared times it by 2x cubed plus 1. That's your f prime. The point is a -1. So find f prime of -1 to get your slope. -1, carefully, 12, -1 squared times 2 times -1 cubed plus 1. Powers first, and -1 squared would be +1, so that gives it 12. -1 cubed would be -1, so that gives me -2 plus 1. So it's a 12 times -1, which is a -12. So the slope is a -12. Any question? So we have the slope and the point. The point is -1 and 1. So again, apply the formula y minus y1 equal to the m times x minus x. Y minus y1. 1 m x minus x1. x1 is a -1. So you make this one to positive, or just write it down, then simplify it. That's it. So this is going to be -12 times x plus 1. You have to distribute it to simplify it. So it's going to be -12x minus 1 minus 12. And I add the 1 to the other side. So y would be -12x minus 12 and the plus 1. So the final answer, y equal to the -12x minus 11. This is going to be the equation of your tangent line. And you're done with the case 1. Any question? So this is going to be the case when the function is given to you explicitly. There is no mix of the x and the y together. So that's type 1. The type 2, of course, going to be when they are going to be mixed together. So that's a 3b. Any question? So I'm going to go to the next page because I need more space to do the implicit differentiation type. So that would be your case, the next case. So it's going to be A, B. There is in the practice is a D and E. No, it must be C and E, which is going to be the same thing. Okay, so this is, okay, that's going to be your 3C. It must be C. In your practice one is D, is the same thing. Okay, so what's this function? The function is given to you implicitly, means y is missing, but it's inside this equation, x to the 4, x squared, y squared, which is going to be y squared. The point is an unusual point, but it's from your book. I just wanted to see that it doesn't matter if they give you something like this. Don't switch it into the decimal number, just keep it. Okay, it would be uncomfortable usually, but it's not, it's good, would be not bad for this. Okay, so you want to find the equation of tangent line. Your point is given to you. You see this is going to be your point. Your point is a radical 2 over radical 2, radical 2. But you need the slope. The slope is, you remember, derivative. Your function is y, so you have to find the y prime. But you have to find it at this point. You see this is the notation that we use as radical 2 over 2 and the radical 2 over 2. What does it mean? This means when you differentiate this equation, you get a combination of x, y, and y prime. Substitute x equal to the radical 2 over 2. Y equal to the radical 2 over 2, then solve for y prime. Okay, so in the previous part, when the function is f, straightforward, we get the f prime. But this one, when you differentiate it, don't solve it for y prime first. Substitute the numbers first, then the y prime. That is easier to know to apply. Okay, so carefully differentiate. We have nothing to worry about the x to the 4. It's going to be 4x cubed. Plus, you have to apply the product rule. The first function is x squared. The second function is y squared. So derivative of the first times second, second first. First one is x, derivative of x squared to x times y squared. But the second one is a y function, okay? So derivative of y squared is 2y, y prime. So let's make sure don't miss that part. So derivative of the first 2x times the second one plus derivative of the second one 2y, y prime times it by the first x squared. Okay, so it's going to be the result. The other side is easy. Y squared is 2y, y prime. Anytime you differentiate respect to the y, powers of the y, we have to apply the chain rule. Okay, so this is the one that I was talking about. You don't solve for y prime now. Substitute, you see, substitute x equal to the radical 2 over 2 at this time. Y equal to the radical 2 over 2, then solve for y prime. See, that would be much, much easier. Okay, so substitute is going to be 4 times x cubed, radical 2 over 2 cubed. It's going to be 2 times x is radical 2 over 2. Y squared is going to be radical 2 over 2 all squared, plus 2y, 2 times radical 2 over 2. Y prime is missing, radical 2 over 2 all squared, and it's going to be 2 times y radical 2 over 2, y prime. So that's 1. You have to do it and simplify that. You can see you can drop one of the radical 2 over 2. So all of them are divisible by radical 2 over 2. So divide, if you like, by radical 2 over 2. Drop one of these, you see, that would be out, out, out. And this is going to be y cubed. You change it to the y squared. Okay, it's going to be 4 times radical 2 over 2 squared. I rewrite it, so it's going to be 2 times radical 2 over 2 squared, and you can do it right away. And plus, and that would be 2 radical 2 over 2 squared. And on the other side, we get a 2y prime. Okay, the number is going to be nice, the one that we give you. But this is from your book. You just want to see how you handle the algebra. Now, simplify this one. Radical 2 squared, you remove the radical, you lose the radical. The bottom one 2 squared would be 4, plus 2 times. Radical 2 squared would be 2, because radical 2 squared would be radical 4, which is 2. But the bottom one 2 squared would be 4. Same thing for this one, 2. And that gives you 2 over 4. And the 2y prime. So there you are, 2 and 4. That give you 1/2. Simplify these two. And
y prime on the left side of the equation.
oh yes, which one is it? This is the one, yes. 1, 2, 3. Yes, thank you. So there must be a y prime here. Y prime, y prime. Thank you. Very good. Okay, let's finish simplifying. So that's going to be 2 times 1/2 because we simplified these two. And we simplified these two. Now we can simplify better, really. I just explain it. It's going to be 2y prime, and that's a 2y prime. So this give you 2. That would give you 1. And that would be y prime. And this is 2y prime. Okay, so everything seems to be all right. So that give you 3 plus y prime equal to 2y prime. And if you y prime, it's going to be like This is it, like a y prime minus 2y prime equal to the -3. So that gives negative y prime equal to the -3. So y prime would be 3. So this slope is equal to 3. Okay, just show you how we handle this in the radical form. Any questions? So we have this slope and we have the point. Although the point was uncomfortable, but we can find it. You know, some people you're not expect to change it to the decimal number if you like, radical 2/2. Otherwise, it would be all decimal numbers all over the places. But y minus y1 equal to the m times x minus x1. Just a little bit simplification. It's going to be 3x minus 3 radical 2/2. You add this radical 2 to the other side. So y would be 3x minus 3 radical 2/2. Okay, plus radical 2/2. So you combine these two together, it's like 3x minus plus 1. $3 minus $1 is going to be $2. So it's going to be y equal to the 3x minus 2 radical 2/2. Okay, it's like -3 plus 1. So these two would cancel out. So the final answer, 3x minus radical 2. So that gives you the equation of the tangent line. Okay, not bad, but it takes a little bit of time to do it. We have a better one, the next one. Okay, so expect one of them. It's a one question, 2 parts. And again, when we get to the test. Okay, so that's a part C. Any question? So I do the part D as well. The part D is implicit differentiation. So just make sure you practice because that point was a little bit troubling. Okay, not bad. Are you ready? Let's get the last one of this tangent line one. It's a good practice because we check the derivative and at the same time the application of that derivative. Okay, so the last tangent line one is this one. It's going to be, it's the set 3e. It's not, because there was a couple of more, I dropped it. That's why you see A, B, D, E. Okay, the last one is, again, this is similar to the one in your assignment. And if you want, just pick one similar to this one in your book if you want to practice. So the point is 1 and 2. Again, a tangent line problem. And they like it because, you have to use a product rule here. And then you use a power rule for the y. So that's why they give you this type. Okay, already. So the point is already given to us. Okay, the point is 1, 2. So nothing to worry about. We need the slope. The slope is derivative of the function. The function is y. So y prime at a point this time. Point 1, 2. So differentiate, replace the x by 1, y by 2, then find the y prime. Okay, so let's go for it. This is going to be 6x squared. And this is going to be 6 y squared, but y prime because of the chain rule. Okay, so it's going to the left, but to the right, you got to be careful. It's a product of two functions. Okay, you can keep the first function to be 9, the other one to the y. To differentiate it, you see, you may think about this one as your first function, or just keep the 9 differentiated. So this is the way I do it. A derivative of the first function is going to be 9 times the second one, y, plus, if you have a second one, you got to be careful, the derivative of y. Remember, the derivative of y is y prime. Because from the power rule point of view is 1, and you have to multiply by y prime, okay? So the derivative of y with the y prime times first, 9x y prime. I gave similar on the test, and some people, they missed this part. They missed the y prime. They write 9x is not. Okay, derivative of the first, 9. If you have a second, y prime times the first one. And that's it. So substitute first, then solve for y prime. So x is 1, y is 2, then we are interested in y prime. Okay, substitute x1, that give you 6 times 1 is squared, 6, y2, 2 squared y prime, y2, x1. That's it. So 1 squared would be 1, so that gives 6. 2 squared would be 4. So it's going to be, I write it down so you know what's going on. Y prime, and that gives us 18 plus 9 y prime. 6 times the 4 would be 24. So we get a 24 y prime. And this is going to be 18 plus 9 y prime. You have to simplify, solve for y prime. So isolate the y primes. So 24 y prime minus 9 y prime. And on the other side, we get 18 minus 6. Okay, so that gives you 15 y prime. And okay, and this would be 12. So the y prime is 12, 15. We simplify by 3, that gives you 4/5. So this slope is going to be 4/5. Any question? Now we are ready. The slope is 4/5 and the point is 1, 2. So equation of a tangent line. Y minus y1, y minus 2. The slope 4/5 times x minus x1, 1. Of course, you have to simplify it. You multiply the 4/5 inside, 4/5 of x minus 4/5, and you add the 2. So y equal to 4/5 of x, okay, minus 4/5 plus 2. 2 times 5 is 10. Negative 4 plus 10 would be positive 6. So it's going to be 4/5 of x plus 6/5. The final answer. Equation of a tangent line. Okay, so that would be, again, you have to do both of them in one question. So it takes time for the test. But, check it for the quiz, you'll be ready for it. Just make sure don't miss those small points, like derivative of a second times first. Of second one's y prime. So again, you have a similar one in your in your assignment. Just pick one of them, just try again, and you will see it when we get to the test. We give you those your next extra one. You will see one of them over there. Okay, so that would be our third problem. Third problem, tangent line. 2 cases as we did it. Case 1, apply the chain rule. Case 2, okay. Case 2, you have to apply the implicit differentiation. So that gives you, so far we did 4 problems, in fact, okay, 4 problems. So we need 2 more. So that 2 more are coming from related rates problem. Remember, related rates, everyday life, these x and the y are all kind of fixed numbers over here, the x. So y is a function of x in this type of problem. We talk about it in everyday life. X and the y are going to be dynamic. Okay, they're going to be moving. X is going to be a function of time. Y is going to be a function of time. At different times, you're just comparing these rates. Okay, unemployment rate, your stock rate, etc. So that would depend on time. So we are going to have different notation. So we go to the related rates problem. Remember, we discussed 3 problems for you, 3 cases. So out of these 3, we usually give you 2 because these are going to be the best format. No abstract form. Okay, so we give you a kind of application type. So this would be related. So our next problem, 2 problems would be related rate. Related, okay, related rates. problems. Okay, so the idea is you have a function y is a function of t. And you already got the function f is the function of x is also a function of t. That was the idea. So what we like to do, we differentiate this one respect to the t, we find the derivative of y respect to the t. This is going to be called is the rate of y respect to the t. It's like the speed or velocity rate, depends on what function do you have. Is the cost function rate of the cost, profit, price, demands, okay, depends where you are. But for the other side, we have to use the chain rule. Derivative of outside times inside. Outside f is a function of x, so it's going to be dy dx, but times the derivative of inside, remember, it's going to be x prime of x, if you like, which is going to be dx dt. So this is a related rates equation that we are going to use for these problems. Related rates equation. So in the following problem, one of these rates, rate of the x or rate of the y, would be given to you, and they ask for the other ones. So you have to arrange your problem using two different variables, x and the y, and then relate the information to this formula, substitute, get it right away. Okay, so we are going to be interested in one problem was from geometry, very popular, the sphere problem. So that's problem number 4 here. This is a sphere problem. Sphere problem. We're going to be interested in the change in the, what's going to be the rate of the change of the volume or the radius of the sphere. Okay, I talk about it. You should read the problem carefully. They may give a rate of the radius, ask for the rate of the volume, or the other way around. So read the problem. This is different from the one that we did on the during the lecture. So I write it down. So there you are. Read it carefully. If the radius in this problem, if the radius of a sphere, okay, is increasing, or it's the same one. Okay, is increasing at 1 centimeters per second. Would like to find, it's the same one, but you know, you have one in your practice one that is going to be the other way around. Find the rate of, find the rate of a change of its volume. Okay, of its volume when the radius is 6 centimeters. When the radius is 6 centimeters. That's one. You say, check the problem in your book. The assignment, just you have one which is different. In this case, the known one is the rate of the radius, but there is one problem that the known one is the rate of the volume rather than the radius. That would be interesting to check it for yourself, but anyway, it doesn't matter. Solution of these problems is you have to identify what is the given one. Okay, I like to organize it. If you don't like to organize it, you can do it right away, we don't mind. But you have to give us those variables that you're going to use. You have to give us what are you talking about. You see the given rate over here is going to be the rate of the radius. We call the radius r, so the rate of the r would be dr dt. This is given, is 1 centimeters per second. So that's the rate of the radius. So what they ask for, find the rate of change of the volume. So this is the unknown. Okay, unknown rate. Volume would be denoted by V, so that give you dV dt. Is missing. When do you want it? At what position do you want it? Do you want it when the radius is 6 centimeters? When X is 6 centimeters. So that's the information. Now you have to relate them together. You need an equation. You see an equation like this that I did. So what's the equation? Relationship between the volume. So this is going to be relate them together. We call it related equation. This is the volume of the sphere. We give you this formula, or you can bring it to the test. Volume of the sphere is 4/3 pi r cubed. So make sure this formula is handy. If it may be circle, if it's going to be circle, remember we talk about the area pi r square. I gave you the formula the other day. That's it. That is setting up the problem. So we are here. Differentiate. Use power rules, but consider the derivative respect to the t all the time. Okay, I just remind you that we differentiate with respect to time t. You see, the v, derivative of the v, we usually go with the v prime. But you have to emphasize that you're taking derivative respect to the t. So it's going to be rate of the dv dt. If you write the v prime, we don't accept it because you emphasize that you differentiate respect to, because we can differentiate respect to the r, that would be v prime. Okay, so dv dt, make sure you know it. 4/3 pi is the number, coefficient. R cube, apply the power rule, derivative of r cube would be 3r squared, but you have to multiply by the rate of the r. Rate of the r is, is dr dt. So this is the power rule if you like, but you have to multiply by dr dt. Remember, inside all of these are t, function of t. Any question? That's it. So power rule and the rate, that's it. So you simplify it first. So that gives you 4 pi r squared times it by dr dt. Now substitute. You have the dr dt is equal to 1 and the x equal to the, I'm sorry, it's not x, what's that? Sorry. It's the radius, is r. Radius, we denote it by r. Okay, so that's r. R equal to the 6 centimeters, the radius. You can denote it by x by now, but we denote by r here. So substitute dv dt is going to be equal to what? 4 pi times r squared. R is 6 squared times the rate of the r. Rate of the r is just 1. That's it. 6 squared would be 36. Okay, 36, and that would be 4 times 36. Okay, so that gives you 144. 4 times 6, 24, 144 pi. So the dv dt is going to be equal to the 144 pi. We need the unit. Okay, the unit volume in three-dimensional, the volume, the length was given to in terms of the centimeters. So it's going to be centimeters cubes, if you like, cube centimeters per second. So that gives you the rate of the volume. So this means if you increase the radius of the sphere at the rate of 1 centimeter per second, the result that you get for the volume is going to be very high, if you like, very large, 144 pi square cube centimeters per second. You know that this is a balloon problem, if you like. Any question? So this is the complete solutions, okay? So make sure you write it down, that would be better. You organize it nicely, okay? Because you have to relate this together. You see, this is the kind of a word problems, but you have to put it into, you give us nicely your mathematical design and put them together, okay? So you need this formula, make sure you have the formula for the volume of the sphere. You may need the area of a circle. I gave you that one, pi r squared, okay? So that's geometry. Any question? Now, the popular problem, of course, is the ladder problem. And we did one the other day. Okay, so of these three, we usually give you two, not all the three. So this is the next one, number 5. So ladder problem. So you read the problem carefully. There's going to be, you see that's the situation we're going to have. This is going to be a ladder, and you're going to lean this one against a wall. Always use this graph. This distance is going to be X, foot of the ladder to the wall. This distance would be Y, the top of the ladder, okay, to the bottom, to the ground, if you like. And this is going to be always the length of the ladder. In this problem is given to 13 feet. It's coincidence, you know, I give you 13 the other day and today, because it's a nice number for, for using the Pythagorean identity. Okay, now let me give you the problem first. You know, remember we talked about it. You can push the ladder up or you can pull it down. If you push it up or, pull it down, the foot of the ladder, okay, foot of the ladder can go away from the wall or towards the wall. And this Y over here, it go up or down. So the X and the Y would be moving. When they move, they are going to have a speed rate. So there's going to be a rate of the X and the rate of the Y. So in this problem, one of these would be given. They ask for the other one. You have to read the problem carefully to see which one is given to you. If they talk about the bottom foot of the ladder, you use X. If they talk about the top of the ladder, you use Y. Okay, that's it. So let's describe the problem. This is the problem, a ladder at 13 feet, like the example that we did the other day, 30 feet long. Again, is going to be leaning against the wall. It's very similar to the one that we did. They're all similar. Okay, against the wall. Now read it carefully to see what rate would be given to you if the foot of the ladder. So this is different from the one that we did the other day. If the foot of the ladder. Okay, if the foot of the ladder. Okay, the foot of the ladder is pulled away. You see, you pull this one away, then you drop the top one. Okay, is going to be pulled away from the wall. It's going to pull away from the wall at the rate of 0.5. Okay, 0.5 feet per second. So this is going to be 1. Which rate is this one? Is it dx dt or is it dy dt? Any which one?
The X.
The X, very good, because we talk about the foot. Okay, it's going to be dx dt. That's the important part of the problem. If they say the top, is going to be dy. Okay, so the question is going to be how fast? How the top would dropping down. How fast? How fast will? Okay, will the top of the ladder? Okay, the top of the ladder. In this case, it's going to be dropping down. Okay, be dropping. Is going to be dropping when the base, of course. When the base is 5 feet. 5 feet from the wall. From the wall. What is this 5? Is it X or Y?
X.
X, excellent. Base X. Okay, so this is it. So put this information into the given rate and the, okay, so what is going to be your given rate? You've got to be careful about the ladder problem. Make sure to use the proper notation. So given rate, you read it carefully. If the foot, so we are talking about the X. So it's a dx dt is given to you and is going to be at the rate of 0.5 feet per second. That's it. You don't need a negative sign as we did for the y because it's getting bigger. If it was the y dropping down, you need a negative sign because it's going down. Okay, so that's a given one. So the unknown is the other one. Unknown rate is going to be dy dt, which is missing. Okay, that's a missing one. But information, when you want it, you want it when the, you see ladder, when the base is 5. Base means x is 5 feet away. Okay, that's it. Now you need to relate them together. Related equation. You need the equation to differentiate. Related equation. Now, remember what's the related equation? This is it, x, y, and this is a particular triangle. It's a right triangle, remember, we use the Pythagorean identity. So the equation is going to be x squared plus y squared, whatever length it is, 13 squared, which is going to be 169. Okay, this is the collection of the information. Any question? So be careful. Which one is it? X, Y. So the next step is easy. We have the equation, differentiate, change it to the related rate, those ax dt, substitute, you get the result. Okay. So differentiate. I just remind you again. You're differentiating. Remind yourself with respect to time t. Derivative of x squared, power rule would be 2x. But you have to multiply by the rate of the x, dx dt, like u prime. Okay, derivative of the y squared is 2y. You have to multiply by the rate of the y, dy dt. Both sides. If the 169 would be 0. Okay, any question? Make sure both sides of the equation. You know, it's optional, but you can drop the 2, you can divide by 2. So your equation is x dx dt plus y dy dt. This is the equation that you have to substitute, but you check to see if you are ready. And you need the x and the y here. X is already given to you, x is equal to the 5. So y is missing. So we are not ready. So what we do, we go to that right triangle again. So that's a 13. You have the x, this is 5. So this is y. So you have to use a kind of mini particular identity to get it. Mini operation, so it's going to be y squared plus 25 equal to the 169. Okay, all squares. So y squared would be 144. So y would be 12. Okay, it's going to be just positive number because of the length. Now we come back and we substitute here and then we're done. Any question? So we are not done. That's it. X 5. dx dt 0.5. It's given to you. Plus y 12. dy dt is missing. 0. That's it. That give it 2.5. Okay, and just move it to the other side. So it's going to be 2.5. So that gives us a 12. Dy dt equal to the negative 2.5. So solve for dx dt. Okay, so I put it here. Dy dt is going to be negative 2.5 over 12. You can use your calculator if you like, or otherwise, if you want to leave it, you have to simplify it. You can drop that decimals, but add 1 0 down the denominator. Okay, that gives you 120. Then you can simplify it by 5 if you want to say, leave it as is. So if you simplify by 5, that gives you negative 5 on the top. And if you simplify this one by 5, so that gives you 24. So dy dt, it must be a negative number because the top would be dropped down. 5 over 24, but of course, feet per second. So that gives you the final answer. Okay, it's a very interesting problem between those three cases that we have. They prefer this one, but read it carefully. And when when you organize this everything would be the same in different problems that you have. But the question is going to be, which case is it? Is it the first case or the second one? Okay, any question? So that's a ladder. Let's do the last one. The last one is the lighthouse problem. Remember, revolving light problems. This is the one that we have to use a kind of trigonometric equation or function to take care of it. So it's all the same. They talk about the police car, lighthouse. There is a in your book, boats, just by the shoreline. This is the type that we're going to have. Okay, so this is number 6. Kind of revolving light problems. That is going to be the case. Let me write it down because I needed to have it here. So in this case, they put we have a radar antenna in a boat above, you see, close to the shoreline. Let me write it down. This is maybe from your book. There is a one point about this problem I'm going to explain. A radar antenna. Okay, this is it. A radar antenna making, I'm going to explain this extra expression that you have over here. Okay, a radar antenna making 1 revolution. Okay, 1 revolution every 5 seconds. Every 5 seconds, go around the circle. They give it a kind of angular velocity, but they express it into this type of forms. So is going to be located on a ship. Located on a ship close to the shore. Okay, that is. We give a lighthouse the other day. This is an antenna in a ship, which is going to be 6 kilometers from the shoreline. Okay, 6 kilometers from a straight. Okay, a straight shoreline. Okay, so like you have those revolving light at the distance of the 6 kilometers from the shore. So as usual, you want to know how fast you get a kind of a spotlight or a spot of a beam. How fast is this time the radar beam? Like the police car. Okay, radar beam moving along the shore. Okay, moving along the shoreline, the line. When the beam makes an angle of 40 degrees, makes an angle, okay, of 45 degrees. 45 degrees with the shore. With the shore. Okay, that's it. And they explain it for you that this is something that you have to use to find the angular velocity. So they give you the hint. And the hint is that one revolution, when you go around the circle, the revolution is equivalent to the 2 pi radian. We usually give you the velocity right on, but in this case, they give you the number of the, see, they say one revolution every 5 seconds. So one revolution would be equivalent to the 2 pi radian. If you want to find the velocity, which is a radian per second, it's going to be 2 pi over 5. That's something extra that you have. Okay. So basically, it's like the work problem that we did the other day. So this is going to be the shoreline. Okay. And this is where the antenna is going to be. Okay. Antenna. And this distance is 6 kilometers. Okay, that's a 6 kilometers that you have. And the beam of the radar to the shore is this one. So this distance is X, is moving around. This angle is theta. The beam angle with the shoreline is 45. Okay, that's it. So we usually, when the beam is 45, we talk about it. This is 90. You find the theta. Theta would be 45 again in this case. So we are going to be interested in dx dt. Okay, we talk about it going to the beam going to the right to the left. So there is two rates that we're going to consider. The rate of the beam. This is the one that we want to find. And for that revolving one, angular velocity of the radar is going to be d theta over dt. Okay. So this is given because they give you one revolution every 5 seconds and one revolution is 2 pi radian. So the unknown one is dx dt all the time. So let me just put them together. Given rate. That's a given rate. The given rate is d theta dt. That is going to be the given one. So one revolution every 5 seconds, one revolution is 2 pi, so it's going to be 2 pi over 5. Remember, it's going to be radian per second. That's the speed of the is revolving for the radar antenna, the waves. So the unknown rate is always the beam rate going to the right to the left. The xdt is missing. When you want it when theta is 45 degrees. Remember, this is not this 45. This is the fact that it's a 90 minus 45 is 45. Okay, like the one that we did there. So if it's going to be 30, the theta would be 60. Okay. Now we need a relationship formula. Related equation. You see, we talk about it. You want the x, which is the opposite sides. You have the 6 with the adjacent sides. So the only thing that we can use is tangent. Tangent of the theta is the opposite sides over the adjacent. You cross multiply that, give x equal to the tangent of the theta. So this is always the equation that we're going to use for this antenna or revolving light. Any question? Easy to differentiate. Okay, differentiate with respect to time t. Derivative of this one was just the rate of the x respect to the t. 6 is the number, derivative of a tangent is secant squared of the theta times the rate of the theta, d theta dt. That's it. Substitute the information that you have. So this is going to be 6 secant square of 45 degrees times it by the rate of the data, which is going to be 2 pi over 5. You have to bring the secant of the 45. You can do it over here or just do it separately. Secant is going to be 1 over cosine. You see, secant of 45 degrees is going to be 1 over cosine of the 45. And the cosine of the 45 is radical 2 over 2. So this is going to be 1 over radical 2 over 2. And use the reciprocal, so that give you 2 over radical 2. So you square this, okay, so it's going to be 6 times 2 over radical 2 squared times 2 pi fifth. Okay, radical 2 over 2 squared, so that gives you 6. The square root of 2, you get a 4, and that gives you 2, and that's a 2 pi 5. Simplify it, simplify by 2, that gives you 1, and that gives you 3. 3 times 4 is 12. 12 times 2 is going to be 24. 24 pi fifth is going to be the final answer. Okay, so this is going to be the rate, the speed of the radar beam. Okay, but of course, the distance was in terms of the kilometers, and the time is second. So this is going to be the rate or the speed of the beam light. Okay, so read it carefully. This is all the possibilities that we are going to have. So keep the solution of this practice quiz also for your test, because we are not going to review this part again. So we are ready for the quiz number 2. So I did 6 topics, and you will see 6 problems, okay? And you can check it tomorrow morning, and you have to submit it by Monday night as usual, as your practice number 2. Okay, after your quiz, we start talking about those maximum minimum in chapter 3. We finished chapter 3. We hope to finish it before your next test. Okay, that's it. Any question? So I grade your test, give you the result over the weekend, so you know what's going on. And also remember, there is a problem sets that you have to submit. I've already posted the number for you. Just pick the numbers. I think in your case 7 or 8. I think that's one of each section. If your section is going to be different, using different edition, that's fine. Pick 7 or 8 from the section that you see over there. Okay, and submit it on time to get your points. That's it. Any question? So have a good one. Just check your quiz tomorrow morning. Just do this one to be prepared, and you got you will see it tomorrow. Okay, have a good one and take care. Bye-bye. If you need anything, email me.
Thank you.
Thank you. Bye-bye.